Alright, this is going to be on ionic bonding, and there are a handful of definitions that you need to get down first. So first of all, an ion, ions are atoms of the same element with a different number of electrons. So we've talked about isotopes, which is atoms of the same element with different number of neutrons. Now we're dealing with ions, so we're talking about different number of electrons. Some atoms lose electrons and are positively charged. And some atoms gain electrons and are negatively charged, and they have special names. An ionic bond is the transfer of electrons from a metal to a non-metal. Metals will always lose electrons and become positively charged. Positively charged ions are called cations. So if you think of cats, cats are a positive thing. There we go, little cat. Cats are a positive thing, so that's why positively charged ions are called cations. Nonmetals will always gain electrons and become negatively charged. So nonmetals gain, they become negatively charged. Negatively charged ions are called anions. So just the non-cation one. The octet rule is that atoms will combine because they want to have 8 valence electrons. The only exception to this rule is hydrogen and helium because they only want 2 valence electrons. So this octet rule is really important because it is the whole reason why ionic bonds occur in the first place. And so I'm going to show you what that looks like with Lewis dot diagrams. So if we wanted to combine sodium and chlorine, we first would write out our sodium and our chlorine. And if you looked on the periodic table, sodium has 1 valence electron and chlorine has 7. And so chlorine really wants an electron. Sodium doesn't mind giving that one away. And so what happens is sodium is going to transfer this electron to chlorine, and so those two elements are going to bond together in an ionic bond. Ionic meaning that there has been a transfer of electrons. And so your formula then would just be NaCl. If we look at potassium and sulfur, you've got your potassium. Potassium has 1 valence electron. And sulfur has 6 valence electrons. Okay, so when they bond together, potassium is going to transfer that electron. However, sulfur is still not happy yet because sulfur really wants 1 more. Now sulfur is going to have 7 and sulfur really wants 8. So sulfur needs another potassium. Okay, now once those electrons have been transferred, sulfur is completely happy with 8 valence electrons. Your formula would be K2S, signifying that you have 2 potassiums and 1 sulfur. Another example, magnesium and fluorine. So magnesium has 2 valence electrons and fluorine has 7. So fluorine wants 8, so it takes 1 of magnesium's electrons, and now fluorine is completely happy. So magnesium still has 1 electron just hanging out, and it just kind of wants to get rid of it. So you need to add another fluorine so that magnesium can transfer that electron. And so now the magnesium is happy and the fluorines are happy. So your formula would be Mg, you only have 1, F2. So you only write that subscript, that little number down there, you only write that if you have more than 1. If you have 1, for example, NaCl, you would not need to write it as Na1Cl1. That's bad. So notice on here that your metals are always the one that are giving up the electrons, and your nonmetals are the ones that are accepting the electrons. And so if you look, because magnesium is giving up 2 electrons, it's going to have a positive 2 charge to it. It's giving up 2 of those negative things. Because each fluorine is accepting an electron, each fluorine would have a -1 charge on it. Instead of drawing the dot diagrams every time you need to see how a compound is going to form. If you look at the periodic table, first column, all these elements are going to be +1 elements. Second column will be +2 elements. And then over by boron, this is +3. And then you go starting nitrogen, -3, -2, -1. And so the elements in those columns are the ones that are going to be forming your ionic bonds. And what that +1, +2, +3 means is that it either has 1 valence electron, 2 valence electrons, or 3 valence electrons that it is going to give away. The -3, -2, -1 means it either needs 3, needs 2, or needs 1 electron. And so when it gets those electrons, it's going to have a negative charge to it. So this is going to make it a lot easier if we go back to our NaCl. If you write your charges in and you look at the periodic table, Na is a +1, Cl is a -1, and so those charges cancel out, +1 and -1, and so our formula is automatically just NaCl. Our other example was potassium and sulfur. And so potassium is right here, has a +1 charge. Sulfur has a -2 charge. So you've got potassium +1, sulfur -2. So those charges do not cancel out, so it's not just Ks. And so an easy way to do this is you crisscross the numbers. 1 comes down here, 2 goes down there. And what that means is that in your formula you need K2, you need 2 of them, and S you just need 1. And remember, we don't write the 1 as a subscript. Let's look at our other example, magnesium and fluorine. Magnesium is a +2, fluorine is a -1. So you've got magnesium +2, fluorine -1. So in order to figure out, because those charges do not cancel out, in order to figure out what your formula is, you take the numbers and you crisscross them. So this tells you that you need 1 magnesium, so it's just Mg, and you need 2 fluorines, F2. And so if you look, these are the same formulas we got from doing our dot diagrams. But it is much easier, instead of doing the dot diagrams every single time, much easier to just look at that +1, +2, +3, -3, -2, -1, and crisscross your charges and get your formulas. Alright, the last thing is naming ionic compounds. So once you figure out how to write the formula, then you need to know what to call it. So the rules are, the first thing is that you name the cation. So remember, this is your positive thing. Typically this always is your metal. Then you name your anion, which is your negatively charged thing, and this is your nonmetal. Number 3, if the cation has more than 1 charge possible, use a Roman numeral to indicate which charge applies. And this is a little bit tricky, and so I am going to show you this in class. But just write that down. Number 4 is polyatomic ions are treated just like a single element. and I'll show you an example of that. And then last thing is an "-ide" ending is used in naming anions. So anions is the second element or that nonmetal. So for example, if oxygen is your second element, so that is your anion, that would turn into oxide. So you take away the gin and you add an "-ide." Another example, sulfur. Sulfur would turn into sulfide. And so let's go back and name the examples that we did previously. Okay, so sodium and chlorine, those are the two elements that you're adding together. Once you have your compound, you name your first element sodium, and then chlorine with an "-ide" ending, so chloride. So that compound would be called sodium chloride. Next one, potassium and sulfur would be potassium. And then sulfur with an "-ide" ending, so it would be sulfide. And then the last one we did magnesium and fluorine, so you would name magnesium. And fluorine would turn into fluoride. Magnesium fluoride. So that is how we name the compounds that we make. To show you an example of polyatomics, and make a note here that you do not change the endings. And what I mean by that is you do not change the ending to "-ide." If you had ammonium, which is NH4 with a +1 charge, and phosphate, which is PO4 with a -3 charge. Okay, we learned when you combine these you need to crisscross charges. And so your compound would be NH4 and you have 3 of them, and PO4 and you just have 1 of them, and you still would call it ammonium ammonium phosphate. And if you notice your polyatomics, ammonium is this thing and phosphate is this thing. And so your endings do not change at all with polyatomics.